Quiz 6, Question 3. A woman wishes to pull an 8.5 kilogram crate 7 meters across a rough floor. She applies a force of 187 newtons, and she will pull so the rope is parallel to the floor. The coefficient of kinetic friction between the crate and the floor is 0.4, and we need to calculate the total work done on the crate as it moves the 7-meter distance. So let's draw this out. And then we have, so that'll be our plane, and then that is the initial position of the crate, and this is the final position of the crate. This distance here is 7 meters. And so what are the forces that are acting on the crate? Well, we know that there is pulling force. We know that there's frictional force. We know that there is the gravitational force. And we know that there is normal force. And what is given in the problem? We know that the mass of the box equals 8.5 kilograms. We know that the change in distance is 7 meters. We know that the pulling force is 187 newtons. We know that it's pulled at an angle of 0 degrees to the floor. And we know that the coefficient of the kinetic friction is 0.4. So now we need to figure out, well, first, what is our formula for work? For total work, it'll be the sum of all the work done for each force. So first we need to go through each force and figure out how much work was done on it. So the formula that we're going to use for work is work equals the force times the change in distance times the cosine. So for our first force, we'll do the pulling force. So the work for the pull equals 187 let me fix that. Times the change in distance, which is 7 meters, times the cosine, and since it's going with the plane, our cosine will be 0. So the pull will equal, my calculator, 187 times 7 times cosine of 0, and we get 1,309, and our units are joules. Okay, so now we'll do the same thing for each of the forces. So for the friction force, that'll be, well, first we need to figure out what the force is for friction. And so that should be mass times gravity times the coefficient of friction times the change in distance times the cosine. And so friction equals, that'll be 8.5 kilogram times 9.81 times 0.4, and that'll give us the force, and then we can multiply that times 7 meters times the cosine of 180, because it's going the opposite direction of the pulling force. The work from the friction equals 8.5 times 9.81 times 0.4. And then we multiply all that by the 7 meters that it changed in distance, and then times the cosine of 180. And that gives us a number of negative 233.48. And then we have the frictional force of gravity, or not frictional force, we just have the work done by gravity, which is equal to, that'll just be mass times gravity, so 8.5 kilograms times 9.81 times 7 meter distance times the cosine of 90 degrees, which will give us 8.5 times 9.81 times 7 times the cosine of 90, and that is 0. The reason it is 0 is because the cosine of 90 is 0, and so since everything is multiplied against that, it is 0, and it'll be the same for the normal force, because that'll be the same equation, and it is also cosine of 90, and so we can just say that is 0. So now we need to add up our forces, or the work done. So work net equals work pull plus the work of friction, brackets around these, plus the work of gravity, plus the work of the normal force. So work net equals 1309 joules plus negative 233.48 joules plus 0 plus 0. So net work done is going to be 1309 plus negative 233.48 plus 0 plus 0. And so our net force is 1075.52 joules. This is our answer.